Hello again. I'm Chris Jones from Team Thermos, and we wanted to give you a brief overview of our project. We are planning on designing a small solar thermal power plant that uses an off-the-shelf solar thermal collector. We've chosen to use an evacuated tube solar collector that is generally used to heat water in a home. This collector could easily be scaled to include any other black body to heat the water. The heated water will then be used to power a small, about the size of a small shoebox, turbine and generator. We plan on building a tabletop demo of the evaporator section containing the collector while simulating the back end of the plant and condenser systems.
Hello, I'm Michelle Tibble, and after we figured out our scope of what we were truly going to build, we put a schedule together to make sure that we could make sure we got our deliverables on time for 489, and also to see what our dependencies were going to be, because between the hardware team and the simulation team, there is a lot of dependencies, with the simulation with John being our biggest one to make sure that we have the information he needs for him to keep moving. My portion of this that I'm predominantly going to be responsible for will be the low side pump driver, which is being designed to be controlled by an Arduino Duo. And what it will do, it will vary the system pump to keep an even flow of our working fluid to keep the gradient to where we need to give the proper power output.
Hi, my name is David Mummy, and the primary area I'll be working on is generating the transfer functions that will be needed to plug into the software simulations that we're going to be using for the back end, as Chris mentioned. In order to get data off of our evaporator, we plan on building a sequence of randomly generated inputs and exposing our solar collector to the solar source, exposing it and then covering it and seeing what it does and measuring with a thermocouple the input and output temperatures of our solar collector. And that data will be used for future experimentation as well as for modeling and software to get a good estimate of what the transfer function of our system is.
Hi again. So this is John Plezga, and first I'm going to walk you through a little bit of the simulation trials and tribulations we had. Initially, we wanted to find a good software that would model what we wanted almost to a T. This does exist. There's a product called EcoSim Pro. But unfortunately, it was cost prohibitive to us. We also reached out to 2 other companies that also ended up being cost prohibitive to us. The other sources we could have used are open source software, some of which include CyclePad, Coco, Energy Plus, and Scilab. For different reasons, we decided not to use these, but did land on the open source software DWSim. Mostly because it has 2 proof of concepts for running an organic Rankine cycle model. The plan is to learn this software and implement these models while also learning to do a traditional Rankine cycle and adjusting it with Simulink and MATLAB. There are guides to this online, and it's just going to take some figuring out on my part as well. So for the future, the next month is going to be me playing with both DWSim and Simulink quite a bit, and going over some hand calculations for organic Rankine cycle and just how it differs from the traditional Rankine cycle. And that is it for me. So to wrap up, this was Team Thermos, and that's our video update.